The topic is Bernoulli differential equations. So let's do this example. We need to solve the Bernoulli differential equation x dy dx plus y equal 1 over y squared. First, let's read the definition. The definition is right here. The Bernoulli differential equation has form dy dx plus p of xy equal f of x yn. So first, let's check if this is really a Bernoulli differential equation. So first we need, see there is no x here, so we need to divide by x. So we can see if it has that form. If we divide by x, we get dy dx plus divide y by x is same thing as 1 over xy is equal, and then divide this by x, 1 over x times 1 over y squared. So you can tell it is a Bernoulli. Why? Because 1 over x happens to be p of x, and then 1 over x happens to be f of x, and this is the same thing as y to the negative 2. So this is like y to the negative 2, which means n is equal negative 2. So we know it's a Bernoulli differential equation. Now to solve it, we have to let u equal y to the 1 minus n. This will reduce it to the first order differential equation. So let's do that. We need to let u equal y, 1 minus n. Well, this means u equal y, 1 minus our n is negative 2. So u is equal y, 1 minus minus 2 is y cubed. Which means, now what do we do? We always solve for y. Let's solve it first. So y is equal cube root of y. Cube root of u, which means y is equal u to the 1/3. Why do we solve for y? Because our goal is, look at this differential equation. Our goal is to have a differential equation that have just the y, the u's, and the du dx. In other words, we need to replace dy dx, and we need to replace every y. And then all we're going to have is the u's and the x's and the du dx. So in other words, we need to find dy dx. So what is dy dx? Dy dx is equal, use the general power rule, 1 over 3 u, 1 over 3 minus 1 is negative 2/3, but don't forget times du dx, because u is a function of x. Now these are the only two things we need. Once we plug them in, somehow the equation has to become first order differential equation. So let's do that. So first, if you look here, let me rewrite it. It's dy dx plus 1 over x y is equal 1 over x 1 over y squared. So first I replace dy dx, and its formula is right here. Dy dx is what? 1 over 3 u negative 2/3 du dx plus 1 over x, the y is right here, it's u, 1 over 3 1 over x times 1 over y is right here again, so it's u 1/3, but you want everything squared. Now this is the same thing as 1 over 3 u negative 2/3 du dx. That's right, this is x negative 1 u 1 over 3 is equal, this is same thing as x negative 1, but this is u. Remember, 1/3 squared is 2/3. You move it up, it becomes negative 2/3. Now of course, to make sure this is linear, we need to, and has that form, we need to divide by, get rid of this term. In other words, to divide, we need to divide by 1 over 3 u negative 2/3. If we do that, we get du dx plus, let me do it in two steps, x negative 1 u 1 over 3, this is 1 over 3 u negative 2/3 is equal x negative 1 u negative 2/3 divided by 1 over 3 u negative 2/3. Du dx plus, dividing by 1 over 3 means multiplying by 3, so let's write 3. X negative 1 we're not going to touch, but u 1/3 over u negative 1/3 means, let me do it here, 1, you do the exponent of the top minus the exponent of the bottom, and this will be 3 over 3, which is 1. So this is u equal, by the way, if you get anything other than u here, like u squared or u to any other exponent, you know you made a mistake, because you know by doing this method we're always going to get first order linear differential equations. Means the u is going to, the exponent of u will have to be 1. Now this is the same thing as 3 dividing by 1/3 multiplying by 3, x negative 1 and u negative 2/3 divided by u negative 2/3. Well, so this makes sense. If you look at this differential equation, this is a first order linear differential equation. It has that form. So now we know how to solve the first order linear differential equation. We're just going to use the integrating factor. The integrating factor will be e to the integral of 3x negative 1 dx. So integrating factor will be e integral of 3x negative 1 dx, which is e 3, take the 3 outside, x negative 1 dx, which is e3. Integral of x negative 1 is ln x. Now use the properties of log. This will be e ln of x cubed, which means it's equal x cubed. So this is the integrating factor. Now let me rewrite the equation. Du dx, this is the equation, du dx plus 3x negative 1u is equal 3x negative 1. Now I need to multiply by the integrating factor both sides of the equation, so that will be, so multiply left by x cubed and right by x cubed. What do we get? We get x cubed du dx plus 3. X cubed times x negative 1 means x squared u is equal to 3. X negative 1 times x cubed is x squared. Now the left side is the same thing as the integrating factor times u prime. Check it, make sure it's product rule, that it's right. So this means that x cubed u is equal integral of 3x squared dx, which is equal 3x cubed over 3 plus some constant. So x cubed u is equal to, simplify the 3, you get x cubed plus c. Now divide by x cubed, you get 1 plus cx negative 3. Now remember the u is what? We're looking for y. The u is, look at the back, we said the u is y cubed. So y cubed is equal to 1 plus cx negative 3. Therefore y is the cube root 1 plus cx negative 3. And that would be our final general solution. And that's it for this example.